And in the next example of a solid edge ST5 simulation, we're going to take a look at convection loads, thermal loads, and see how they work. We need to go ahead and create our study, so I'll go ahead and do that. Steady state heat transfer. We need to identify the two components, the fire pit and the plate, the bottom plate. And then at that point, convection and temperature can be combined with other loads, but in this case we're just going to use convection. And I'm going to go ahead and identify the inside face. Now this is free convection. It's not forced. We don't support forced convection. Free convection meaning that the temperature rises and just affects the things around it. There's no forced energy behind it like a fan or something of that nature that you'd find inside of a computer. I'm going to go ahead and click on the inside face where the fire is going to be, and I'm just going to put it at 400. Let's say it gets pretty hot. I'm sorry, that's the film coefficient. The film coefficient I'm going to leave at 1, but the inside ambient temperature I'm going to put at 400. The temperature around the surface is about 400 degrees. Then I'm going to go ahead and define ambient temperature on the inside faces. And I'm going to leave that at 1, and I'm going to leave that at ambient. It begins at just air temperature, so how it's affected is by the heat below it that's rising. So we'll go ahead and place that. And then for convection on the legs, I'm going to go to a front view, and then I can just select those legs, and we'll set again the film coefficient. Now remember, the film coefficient is basically rate of heat that leaves the surface as a function of the temperature difference between the surface and the ambient temperature. In this case, we want the ambient to be 68 degrees. I also want to point out that when you're working with convection and you get the film coefficient and you're not really sure about what it should be, there's been a lot of studies done as to what the film coefficient should be depending on the situation and depending on the material, depending on the air and stuff like that. And a lot of that information can be found online. There's no set thing to key in here unless you've run studies yourself, or you can go online and find that type of information. Now you'll also notice that we get arrows with convection. Shows you the direction in which it's convecting the heat. And in this case, we're pretty much ready to go. The only thing that we haven't done is we need to create a connection. So we'll just use the auto connector again, which is the quickest way to do this. We only support glued connectors in heat transfer. Once that's done, we can run the solve. It runs pretty quick, solving the heat transfer study, and it should give us our results. Now, what you would expect is as the heat is at 400 degrees, as it rises, it slowly cools off, as you can see going up the smokestack. And then, of course, and that's including the outside air that's helping cool that off, as well as the legs. Notice how hot the legs are up close, but as they get down closer to the bottom plate there that's affected by the outside temperature, it only rises about 10 degrees. It's best to just grab the probe. You can get a better idea. If it's close to 70 degrees outside, and then you're building a fire on top of it, that plate's going to get pretty warm, and it's showing in that it's almost actually almost 100 degrees in that particular point. But when you get away from the legs that are also pushing heat out, it cools down by almost 16 degrees or so. Around the fire, it's going to be pretty warm, and as the legs go down, it's going to cool off. So it's kind of neat how you can get the results back of what this should actually look like. Of course, one way to cool these off would be to build some hollow legs and maybe make them a little bit taller. But in this case, this kind of gives you a good idea of how convection loads work. Convection loads not available, as we mentioned earlier, in beam mesh types. It's only available in the assembly and part environment. You get into the frames or beams, then we don't offer that option there. So that, again, that's just a quick look at the convection thermal load types.